Out of here.
Yo.
Those of you that already log in, you're gonna be stuck on slide 1, so just watch the short video. I'm gonna play it here for everybody once they're logged in. Answer the question. You logged in, RJ? Put that down or it's gonna go to track.
Anybody so me.
Are we all in?
It says near.
Number 1 should be Desmos Fly. Make sure you're clicking on task number 1.
I am here. Wait.
Okay, so it says that we're gonna watch this crazy dog named Twinkie try to set the Guinness World Record for the fastest popping of 100 balloons. So we're gonna press play. Some of you already pressed play. Some of you might be.
I didn't sign in yet.
It's okay.
Is that a puppy?
No, it's a guinea pig.
Okay, so we're gonna watch it again.
Dinosaur. I didn't know.
Again, pay attention to the numbers. How many balloons does he pop at the end of the video? 25. How many seconds do you think it will take her to pop all 100? Take a minute to think about it, and I'll let you go. Type an answer in. You can watch it again. You have the power to watch it on your iPads.
Did you say that?
Huh?
Probably 50 minutes.
Maybe. It says we have to try to figure out how long it's gonna take her to pop 100 balloons. In the video we watched, she popped 25. Try to look at the time, things like that. How can we figure out how much she's going to, or how long it's gonna take her to pop all 100?
Well, if her claws are very sharp, I would say.
A million?
Huh?
So what are we thinking?
20.
Why'd you get 20?
Because if her claws were sharp.
What? Like,
I just
okay.
did a random answer.
Oh, Chris, please help him.
Same quest.
Hi, make sure we're listening.
5 seconds at the top, and then you have 25 balloons, and 25 times 4 is 100. So we just times the 5 seconds by 4.
Okay, are we listening to him? Because that is correct. So maybe you did just randomly guess, I don't know there, with the sharp claws thought process there. But again, to repeat what he said, he popped 25 balloons, and if you look up at the clock, he did it in 5 seconds. So Chris noticed that if I multiply 25 balloons by 4, I get 100. So thinking about proportional relationships and scaling, it's all the same thing. If I scale my time of 5 minutes by 4, how many minutes does that give us? 20. 20.
I actually did do it.
Yes, that's why I called on you and then started losing my mind when you started talking about dog's claws.
Because they're really sharp. And I also did guess.
And look, how does it happen that your answer randomly got put up on my screen? I'll tell you what, RJ.
Roasted.
That was not at all what that was. Okay, so now you have a sketch. So think about what we talked about. Think about how Chris explained that he found that answer. Think about what we've been talking about with the graphs. What do you think this graph would look like? It's just a sketch, so it doesn't have to be accurate. What do you think the graph's gonna look like? Seconds is on the x-axis, balloons is on the y-axis. What do you think it's gonna look like? Do a whole graph, not just a point. What do you think the graph's gonna look like?
Can I go for my robo up?
Go ahead.
Yes, you did. You guys didn't have that.
He's something else, I'll tell you what. Did you draw your graph? Again, the sketch doesn't have to be accurate, just what do you think it would look like, what would the shape look like? Okay, Sato, we're on task 1, which is the Desmos, not the mirror body.
Yeah, it's the exact same thing.
That's why. So I'm looking at your graphs. Some of us are doing some crazy funky looking things. Okay, what do we think the graph's gonna look like? If I drew this and you guys tell me what to do, what should I do? Okay, so Parker's holding his iPad up and he's saying like this. Those of you that are at home can't see it. And he kind of just did this, right? Parker, that's basically what your screen looks like.
No. It's like this.
Yeah.
Right there. No. What you want to show you?
No, we're good. It's close. Sydney?
I put like the 20s, the 25 balloons for the 5 seconds.
So Sydney came over and plotted 25 balloons, which might have been about here, maybe 5 seconds, and plotted a point and then connected it. Do we agree that that might be why that graph looks like that? Why do we think it would be that nice straight line? Do we think the situation is proportional?
Yes.
Time and balloons popped? Because that's what Chris did when he multiplied it, he kind of scaled it up. 25 times 4 is 100, 5 times 4 is 20, so we're doing that scale factor. So it's proportional, so we think it's gonna be a straight line. A lot of you at home are sending the same thing, straight lines, some different looking stuff. But for the most part, everyone thinks it's gonna be some version of this straight line. So now I'm gonna change your screen and we're gonna see actually what that graph looks like. So you can see our prediction here, whatever you guessed. If I press play, the graph is going to build and we're gonna see what happens. So what's happening with the graph? Huh?
Outside in the hall.
I don't know what you're saying. Sydney?
It's going with the police.
It's going like a curve. So it's not following that nice consistent pattern like we were saying. Why do we think it's curving like that and it's not just a straight, time's going the same, he's moving the same?
Because it goes over operated.
Exactly. What does it say? Did you read what his?
Yeah, it said if you use the Google Meet, it's a plus time.
Okay, that's okay, sure. That's fine, you're so in here, it's fine, all's good. But why do we think it's curving? What do we think that's happening? Chris?
Because, they didn't do it in like the same amount of time that like we thought it would.
Right, so
Because not everything is perfect.
exactly. Okay, so we're in his mindset of in the math, it's proportional, it's consistent, he's running around in a circle at the same time and he's moving at a constant pace. But you think that dog's getting tired after a couple seconds and he's running around and he's not going in a pattern. So what we think might be proportional, it's not really working out like that because there's all these other real life factors coming into play. Everything's not perfect like Chris was saying, okay? So to finish that up, switch your slide just to reflect. Why do you think we have that difference between what we guessed or we all drew that nice straight line? Why, in your own words, explain it's actually a little bit curved? So think about what Chris just said, think about what we just said. Why is there a difference between we thought it was gonna be this nice, perfect, proportional relationship? We watched the video, the dog got a little bit tired. Why do you think it's curving a little bit? Type your answer in there. When you're done, close out of that and go into the second link. I'm asking a lot of you today. I'm asking you to do 2 different platforms. 2 different things. Why do you think the line curved? So think about what we were saying about the dog getting tired. It's not proportional. It's not gonna be perfect. You're just answering that. And then once you're done and you type in your answer, close out of Desmos, open up link 2 in Google Classroom. Nearpod, gonna be a jack-o'-lantern. It says Happy Halloween. No.
Why did you say chocolate mania then?
Wait, what's it? Happy Halloween?
Yep, once you're done, log into the Nearpod, which is the second link, and you're gonna see this. What?
You know those food commercials?
No, what?
I love food commercials.
Okay, can you follow the directions?
Yeah, but this usually doesn't work for me.
Our conversations are over. today.
I know. But I love food commercials, they're so good.
Yes, but then in real life, they're like nothing.
Finally, another.
They just make my mouth water.
That is true.
Like, you know those food TikToks?
Okay. Okay, so we're logging in.
Good lesson.
See the jack-o'-lantern that says Happy Halloween. RJ, I don't care about the food commercial.
I love food commercials.
I don't even know what you're saying. I have no idea what you're saying.
No, it does.
That's a hard drive of food commercials, I just know it.
Okay, so everybody in here is logged in. Keep in mind kind of how we just talked about that balloon problem, how Chris found the answer of scaling it up. We're gonna look at, this is really just a review of proportional relationships. We're not doing any graphs. We're gonna look at kind of a different situation. So the next slide is going to be a video. I want you to watch the video. I'm gonna play it on here so you guys don't really have to press play on your iPad. At home though, you're gonna press play on your iPad. And I just want you to think about what are you noticing in the video? What are you wondering about the video? When the video's over, we're gonna go to one of those collaborate slides where you can put your answers in.
What do you say?
Okay, so we have to watch. Are we ready?
There's two old men teaching us stuff.
Oh, they really.
They're dead. He looks dead.
They probably had a food fight. Oh, they're magical. I'm starting to go all around the houses and starting
Mini
big
Reese's.
Think about it in your head.
Reversed.
What did you say?
Video's reversed.
Yes, it is.
Imagine they have magical powers, obviously.
I said that.
It is. It's supposed to be reversed. There's no volume on this one. Again, we're just thinking about what are you noticing? What are you wondering? You're saying things out loud, which is okay, but the next slide, we're gonna kind of put that all in.
Now he has glasses.
I don't know why that just came up like that. That was not supposed to happen. Okay, so again, here's your slide. Type in anything you noticed about it, anything you're wondering about it. Remember now we know how to add those pictures, so. You okay, Sydney?
It says it's not found.
Does anybody else just say that?
No.
Maybe try to back out of it and log back in.
I spell candy.
CANDY.
See.
So a lot of us are noticing it's in reverse. One of them is eating Hershey Kisses and the other one is eating chocolate circle things. Parker was asking if they were, what were you saying, the Reese's Puffs? They're
Mini Reese's.
Mini Reese's. So one of them was eating chocolate kisses. One of them was eating like chocolate pumpkins. So they're just like basically a circle chocolate, but it's just a pumpkin.
Maybe like those little tiny decoration pumpkins.
Mm-hmm.
I thought they were just for decoration.
Well, some of them are candy.
Oh, they're edible.
So, and then some of us are wondering, how did they eat them all? Looks like candy corn. They're eating the chocolate. How much chocolate did they eat? Is it giving them a stomach ache? Things like that.
Oh, did you know that candy corn, you can actually make a corn out of it?
That's what the
look.
picture is.
The picture?
Huh?
Look at the picture that I'm pointing at.
My picture?
Okay, anything else we want to add about the two people eating the chocolate? Again, it is in reverse. They ate a lot of it. We're not sure how much it was. We're not sure really what they were doing. But that's probably, Heather said that's probably going to be me later tomorrow night. So you could tell from the beginning that they had a stomach ache because it was in reverse. So it looks like they ate a lot. Heather kind of just said the same thing. I'm not really going to read what she said though, but yes.
Slow down real quick. Slow down.
I can't go any further than that.
I put the candy United States.
Oh, I saw that. Okay, so here's our next slide. How much do you think they ate? So you can't write on this, so we're just gonna kind of talk about it. So we saw the video. How much candy do you think they ate?
A lot.
A lot?
million.
A million pieces?
maybe 25.
May-
Cookies.
Because if you like keep reversing it, you can see
Cookies.
how much.
Okay. Levant, what are you saying?
50?
50 pieces, Janice? 20 each? Any other answers? Heather? 30?
35.
35, so we're gonna play a game, who do you think can get the closest? 10 each? What'd you say?
I'm good at
20.
guessing numbers.
Wait, no, I said 25.
You said 25, Seamus said 20. What? 25, anybody else wanna make a guess?
24.
My guess is.
What do we get if we guess it right?
Bragging rights.
Yes!
But you have to have your mask on if you're right.
Oh, you should have said you don't have to do math for a day.
Nah, well, you don't have to do any math tomorrow.
Math. Ow.
Well, technically we do.
I'm not gonna do that slide. Okay, so now we're gonna watch this. So look at the series of pictures.
I clicked the webpage.
You don't have to click on anything. You guys, it's just gonna play on your screen. So look at it quietly. Look at the series of pictures and try to think about what it's telling us.
If you melt it down into chocolate.
Okay, so it's melting it down into chocolate.
I accidentally hit
Look
down.
at the apple and the chocolate, your chocolate apple.
One is 17 milligrams, and the other one is 8.5 milligrams.
One is 17 milliliters, one is 8.5 milliliters. There's one other thing that we're missing in the video,
One is half full.
okay?
Caramel apple lollipop.
What goes with chocolate?
Okay? So we can see the melted picture. What does the non-melted picture show us?
That there's 3 little balls, and there's one big one.
So I have 3 pumpkins, listen, 3 pumpkins melted down to how many milliliters?
17.
17 milliliters. 3 Hershey Kisses melted down to how much?
Wait, watch how they put that.
8.5.
It's like a fish.
Okay, please stop and listen, because you need to understand what I'm saying to move on. Okay, we're noticing that 3 chocolate pumpkins melted down to 17 milliliters. 3 Hershey Kisses melted down to 8.5 milliliters. That is key for us to move on. Parker?
Aren't those are chocolate pumpkins? Because they look like chocolate cherries.
It's a pumpkin. It might be like a chocolate cherry, but like a holiday version, like a Halloween version. Okay, but again, key to understanding and moving on is that 3 of the pumpkins melted down to 17 milliliters. 3 of the Hershey Kisses melted down to 8.5 milliliters.
We do 25, I wanna brag.
Okay? So now we have a little bit more information about the 2 guys. Please stop talking while I am so we can hear what's happening. We have a little bit more information. What more information do we have about the 2 guys? RJ?
The pumpkins, he ate 111.6 millimeters. And the Hershey Kisses dude ate 55.8 millimeters.
Okay, so I know a little bit more information. I don't know how many pieces of candy he ate, but he ate 116 milliliters. I don't know how many Hershey Kisses he ate, but he ate 55.8 milliliters. So I'm gonna switch your slide and kind of leave you off on your own for a couple seconds, minutes, whatever. How many Hershey Kisses do you think were eaten? Again, that's why it was key to notice that series of pictures where we said 3 Hershey Kisses melted down to be 8.5 milliliters. Does anybody want a calculator?
We have to divide the by the number.
I don't know. Anybody else?
All tonight.
Why, you want a calculator?
Okay.
Again, key to knowing and recognizing from that series of pictures that 3 Hershey Kisses melted down to 8.5 milliliters. I'm repeating it so much because those of you at home can't see, I wrote it on the board.
Wait.
But I just wrote it in marker.
That's my calculator.
Boundaries, RJ, boundaries. My space, your space.
What's that? I don't know anything you're talking about. 5? Yeah, 8.5. I didn't.
And I know, like, the background's hard, but if you pick the white pen, you'll be able to see it a little bit better. Again, 3 Hershey Kisses melted down to 8.5 milliliters. So how do you figure out how many Hershey Kisses there were? I'm not gonna go over this answer until the end. We're gonna summarize different methods to do this. I'm giving you time to figure this out, hit submit, send in your answer, remember your answer, so when we go over it, you can check it. Oh, I just saw your message, Kai, I'm sorry. But the key piece of information here is to know that 3 Hershey Kisses melted down to 8.5 milliliters. So you can use that piece of information. What? Did you submit your answer?
Yeah.
What'd you say?
I said 6.5. I divided 55.8 divided.
So what are some of the answers that we're getting?
Oh, no, 2.5.
42?
What?
What'd you get?
6.5.
6.5? Anybody else something different? 0.5? Anybody else?
Shut up, Andre.
Okay, I'm not gonna go over the answers to this until the end. So I just want you to think about your answer. Anybody get anything else that's different? Okay, some people at home got some different answers. I'm gonna read them off. Gwen got about 19.7, which rounds up to 20. Some other people got 42, 55. So we're kind of all over the place here. So that's great. Okay, same type of question. Try to find your answer here. How many pumpkins were eaten? So again, it's key to knowing and thinking about what we talked about. 3 chocolate pumpkins melted down to 17 milliliters. 3 chocolate pumpkins melted down and were equal to 17 milliliters. So if he ate 111.6 milliliters, how many chocolate pumpkins is that? Find your answer, submit it. We're gonna go over it all.
I say you.
Key piece of information is that 3 of those pumpkins, when melted down, is the same as 17 milliliters.
My ears are big.
You just put it all.
Hey.
I don't think you can hear me.
You get your done now.
Was that an answer? Is that an answer?
Because he has been rude to me for 2 days straight.
Actually, you can do one.
Well, she doesn't say anything that I'm annoying. So you know, he gets a thumb down.
So what are some of the answers we're getting on this one?
6.3.
6.3,
37.2.
37.2, anything else?
You know how I got it?
Yes.
I did 111 point, what was his answer? 6 divided by 17.5, which was the millimeters where they melted it. And I got 6.37714.
So RJ is saying something that's real, listen, he is saying something that's really important. He took 111.6 milliliters, divided it by the 17 milliliters, and got 6.5. But that's just the constant of proportionality. 6.3. That's just the constant of proportionality.
God dang it.
So how would that change the answer a little bit? I'm not gonna tell you, not saying you're entirely wrong, saying you are saying something that's important,
I'm ready.
okay? I'm gonna switch the slide so we can see what happens.
Eyes up front. Chocolate man. He's looking at me like, It was 11?
It kind of looks like candy corn.
Dang, you're gonna get that.
They already are.
Or just learn the life rate.
I think 2.
Wait, 11 plus 11 is. I was close.
I said the thing that you were doing was really, you're just missing one teeny tiny step. And I'm gonna go over it and write it all out so we can all see what we're doing, because a lot of us were doing that same thing he was doing, just missing something.
I said 23.
You said 25.
Both of which, no offense, are not correct.
What?
I hate to bring it to you.
22.
them eat. Look at them eat. They're like.
20.
Bro, I'll be eating that candy real much quicker.
Wait,
I'll just put the wrapper in my mouth and unwrap it like
Okay. So Seamus guessed the right answer.
that. Seamus, get
Some
out.
of us were close. Some of us, and I'm looking at the answers that were at home, did the math, and it worked out to be about 9.6, 9.7.
But
and
I
we're rounding
fixed
it out. What I need everyone to do, everybody that's in here, is look up front. You're done with your iPad. You don't have to write anything. We need to go over how to do this because we all here, we're kind of all over the place, which is okay. Okay? But we're gonna do this using the constant of proportionality, which is exactly what RJ was explaining. Okay? So we're gonna set up a table,
no.
the number of pumpkins and the milliliters. Okay? So how many pumpkins were in that first picture that just kept changing?
Home and middle.
How many pumpkins did we first look at? The 3 pumpkins.
Million.
How many milliliters was
17.
3 pumpkins? Chris? 17. So I can write a table for that. Then I knew a little bit more information. I knew that the guy eating the pumpkins ate 111.6, right? Yeah.
No, you weren't.
Milliliters. So then RJ said, well, all I did was divide my milliliters, so he did, what'd you do, 111.6 divided by 17?
No.
RJ?
0.5. 17.5.
It shouldn't be 0.5, it's 8.5, just 17. So everybody in your calculator, what is 111.6 divided by 17?
I don't need to do it because I already did it.
6.564.
6.56. Okay? So then if I know that value, and it's like not writing very nice right now, what can I do with that value and my 3 pumpkins to find this final answer? Heather?
111.6 divided by.
Nope, I found my constant of proportionality or my scale factor, 111.6 divided by 6.5 gives me 17. So how can I figure out how to scale my pumpkins up? In your calculators, take 3 pumpkins times your scale factor of 6.5, and what do you get? Cindy? 19.5. So do you think either of them ate a half of a piece of candy? Do you think they just bit a Hershey Kiss, bit it in half and threw it away?
Yeah.
No.
No. So 19.5 pieces rounds up to what? 20. Okay? So Jameis, like I said, was correct in his guess.
Seamus cheated. He watched this already.
Okay? But it's that idea of the constant of proportionality. The same thing we did in the beginning with the dog problem. 25 balloons scaled to 100 is multiplying by 4. So if I have 5 seconds, I can scale that by 4 also. If I know 2 pieces in a table, you can find that scale factor between them, scale the rest of it up. You could also take 17 and divide by 3, scale it that way. All the same type of thing, okay? Are we good with that? Okay, so that is the end of that. So if you're at home, you can sign out. There's a little bit less than 10 minutes. Check back in 9th period for your attendance. There is no homework assignment. So those of you at home, check in. I'll let you know if you're missing anything. A good amount of you did not do the practice problems from yesterday, so I'm gonna tell you to do that, okay? You guys, yes.
Can I do it? Oh, yeah.
Or did it, what is it, you can't have it.
Oh, that feels weird.
What?
Ooh.
There's only 3 of them left.
Have you ever bit?
3 of them.
Have you ever bit a rubber Gatorade bottle with a canine piece and it
You
hurts?
ever just get a pure guess and then you get the actual answer? Yeah, that's me.
Yeah, you cheated. You watched this
I
already.
had time.